Okay, so let's go through some examples of factoring these trinomials that have a is equal to 1. And so here I see for problem 1, I have x squared minus 8x minus 20, and I see that my a is equal to 1. So that means I can go ahead and start with that same step of finding two factors that multiply negative 20 and add to negative 8. So I'm going to have negative 20. And I want them to add to equal to negative 8. Now thinking through this, since they're multiplying to negative 20, that means that one factor needs to be positive, the other needs to be negative. And since they're adding to a negative 8, that means that the bigger factor needs to be negative. So first one, I have 1 and negative 20, and then 2 times negative 10, and then 4 times negative 5. And now looking at these pairings, I see that 2 plus negative 10 gets me negative 8. Now normally we would use that to split the middle and go on, but since I have a equals to 1 here, there's no number in front of x squared, I can go straight to saying that my answer is x plus 2 times x minus 10. And then I can always check my work by doing my double distribution. And so if I multiply x times x, I get x squared. X times negative 10, I get negative 10x. 2 times x, I get plus 2x. 2 times negative 10, I get negative 20. Combine my middle terms, and I get that x squared minus 8x minus 20, which is exactly what we started with. So I'm good. So you can always check your work after you factor. So for this next one, we have x squared plus x minus 56. So here I see that I have a 1 in front of my x squared. In other words, there isn't a number in front, so that means I know I can do it with this method. Because again, it's really important to remember that if there were, for instance, a 2 here, I could not use this method. I would need to use my AC method like we did previously. But this one has a 1, so this means I'm looking for two numbers that multiply to negative 56. And then add to my b term, which since there's not a number here, there's really an invisible 1. So I'm looking for this to add to 1. So since it's multiplying to a negative number, that means that one number needs to be positive, the other needs to be negative. And since it's adding to a positive 1, my smaller number needs to be negative. So I'll have negative 1 and 56. Negative 2 times 28 gets me 56. And then negative 7 times 8 gets me negative 56. And so I see my 2 here. Negative 7 times 8 gets me negative 56. And negative 7 plus 8 gets me 1. And so my answer is going to be x minus 7 times x plus 8. Okay, number 3, I have x squared minus 6x plus 9. So I have a is just equal to 1, so that means I can do this method, this shortcut. And so I'm looking for two numbers that multiply to c, which is 9, and add to equal my b, which is negative 6. Okay, so since it's multiplying to a positive 9, that means they're either both positive or both negative. But it's adding to a negative 6. So that means that both of my factors are going to be negative. And so I have negative 1 times negative 9 gets me 9. And then negative 3 times negative 3 gets me 9. And I see that negative 3 plus negative 3 gets me negative 6. So my answer here is going to be x minus 3 times x minus 3. Or you could go ahead and write that as x minus 3 squared. Okay, now for this last one, I see I do actually have a number in front of x squared. So initially, you may think of going ahead and using the AC method here because I have a number in front. But you have to remember that your first step is always to check for a GCF. And I see since all of these coefficients, 2, 18, and 36 are even, I can divide out a 2. I can factor out a 2. So I'm going to factor out 2 from each of those. And that leaves me with x squared plus 18 divided by 2 is 9x. 36 divided by 2 is 18. And now I have a 1 for my a value, so I can use my shortcut here. So here I'm looking for two numbers that multiply to 18, but then add to equal 9. Since everything's positive, my 18 and my 9, then all my factors are positive as well. So I have 1 times 18, 2 times 9, and then 3 times 6. And I see the two factors that add up to 9 are going to be 3 and 6. And so my final answer here is just going to be a little different. I'm going to have a 2 in front now, but then I have x plus 3 and x plus 6. So whenever you factor out a GCF, make sure you do not leave it out of your answer. It's going to need to be out in the front right here.